Welcome to Civil Engineering Knowledge Channel. Yeah, this is as I said this is part 2 where examples for shear force diagram and bending moment diagram is being explained in this video. See, when we go for any kind of a competitive exams or a gate, there it is very necessary that you people need to identify answer without any calculation, because the required amount of a time or the time given for solving particular question may be 30 seconds or 1 minute. So at that instance these tricks are very much helpful, as if you go to my previous video you can find that I have given for different types of the loading conditions how you can draw the shear force diagram. In the similar way, vice versa, you can go for bending moment diagram also. So if there is a rectangle in shear force diagram, you need to make it as triangle in bending moment diagram, and if there is triangle in bending moment diagram, you should make it as parabola. Okay, you should make it as parabola in bending moment diagram. So if there is a vertical straight line or a straight line here, you should make it as a rectangle. So you can observe it here. So I will explain here bending moment diagram. Before that, I'll go to the note part. So here it is given that if there is rectangle in shear force diagram, then triangle in bending moment diagram. And if there is triangle in shear force diagram, then parabola in, it is not parola, it is parabola. Okay, it is parabola in bending moment diagram. So if the sign is positive, the curve is increasing. If the sign is negative, curve is decreasing. So this is the note points. So these points you need to remember so that it becomes easier to identify the particular bending moment diagram of the shear from the shear force diagram. Okay, let us see the first example. Okay, here you can see that there is RA reaction which is facing upward. So from this reference line, this is your reference line, from this reference lines we have taken it up. Then there is no load, so here one horizontal line. Then there is a load pointing downward, so I am drawing the line which is pointing downward, the reference line. Then here there is no load, that means in this portion no load is acting, so I have drawn a very straight line which has no shear. Okay, then here it is pointing upwards, so I am drawing this upward. Okay, so this is how the shear force diagram. If you come for bending moment diagram, you can observe only this part. Okay, so this part is a rectangle. So here in bending moment diagram, see, if you consider this, you can note up to this point, this is a rectangle. So up to this point it is increasing triangle. So here you can find out the triangle is increasing, because in the note you can find if the sign is positive, the curve is increasing. Here you can find the sign is positive, so the triangle is increasing up to center point. Okay, then it is negative. You don't mind about this center line and all. The portions you need to concentrate in bending moment diagram. So if there is positive, the triangle is increasing. Here once again it is a rectangle and the sign is negative. So rectangle means in bending moment diagram it should come triangle. But since it is negative, the triangle is in decreasing manner. So this is a particular bending moment diagram for this question. Okay, when we move to the cantilever portion, so whenever the moment is present in the question, it doesn't matter for shear force diagram. Okay, for shear force diagram, this moment and all doesn't matter. This comes into existence when you draw the bending moment diagram. Okay, and in this case you can find it out. The reaction is upward, so the line goes upward. Here there is no load acting, hence it is horizontal line. Then it is downward, here the load is acting, so I have made it as downward projection. Okay, so this is SFD. And when it comes to BMD, when it is a rectangle, it is triangle. But one thing you should remember, whenever there is a moment acting or a concept, when there is a concentrated moment or a moment acting in the question, you should draw a vertical line. That is one more very important point while drawing the bending moment diagram. Since it is cantilever, even though this is positive, since there is moment, there is a vertical line. This is the reference line. Okay, since it is cantilever, because you can identify that the tension or the bar is provided on the top, right? This top portion, the bars will be provided, so this projection will come downward. And since it is a rectangle, okay, one more thing, and since it is positive, it is an increasing triangle. Understood? Or else, if you may think that this is downward the reference line, that means it is coming downward. It is not like that. Since it is a cantilever with the concentrated moment or a moment is acting there, in cantilever you are providing the bars at the top, so the line will come downward. And since it is a rectangle and a positive, it is an increasing triangle. So here you can observe it is a very straight line. You can directly draw a triangle to that. And see, these are all the very simple examples that I have given for particular shear force diagram. How can you draw the bending moment diagram? So one more thing you should remember here, if the beam is sagging, for example, this portion is called sag and this is called hang. If the beam is sagging, it is considered as positive. If it is hogging, it will be considered as negative. This I had used only for sign convention purpose. Okay, so now remembering or keeping this all examples as a reference, I will draw one complex beam where you should understand how to draw both shear force and bending moment diagram. See, in GATE or any other very competitive exams, what they'll do is they'll just give you this question and they will give you set of diagrams either to identify one is shear force or else bending moment diagram. So if you come to shear force diagram, you can easily find out. See, the reaction is topward, so here it is upward. Then it is a uniformly distributed load, which is in the form of a rectangle with downward arrows. So it is triangle which is straightly going downward. See, this portion has moved downward. Here there is no load, so it is straight line. And here there is topward arrow, it went up of the reference line. So till here, okay, till here there is no load, so there is straight line. But here, but this moment will not consider for SFD. So since there is no load, we have drawn a straight line. Draw downward arrow, so we will draw the line downward, the reference line. Then there is no load, straight line, it went upward. Okay, so this is SFD. So this is positive, this is positive, this is negative. Okay, and this is also negative. So by seeing this, see, you can easily identify this is triangle. When there is rectangle, you will draw the triangle. When there is triangle, you should go for parabola. One more thing, it is positive, so it is an increasing parabola up to this portion. Okay, then there is rectangle, but it is negative, so it is decreasing parabola. Then at this point, up to this moment, because moment will be considered in case of the bending moment. So up to this point, it is, since it is rectangle, it is increasing triangle, but at this point you can identify a drop. That is because whenever the moment is present in case of any beam, you should draw one vertical line. Okay, since it is pointing downward or going downward, we had dropped a line downward. Okay, and you can see there is a continuation of the rectangle which is positive. So I have drawn the increasing triangle. Here it is a rectangle, but it is negative, so it is a decreasing triangle. So with this complex beam where different loading conditions are present, so with the help of this, where if you understand this like nearly, see this depth, height of this line and all, that is depending upon the calculations. For competitive exam or any interview if you attend, if they tell you to draw randomly, you should be able to draw a very rough diagram of a particular figure given. So that is the reason I had made this video, and I hope this video is very helpful to you people. And yes, I will make a very interesting concept in next video. If you want the videos to be continued in a manner, or if you have any queries, just post it in your comment box, so I'll just answer to those queries. And please like my channel and share the videos as much as possible to your friends, so that this may be helpful for them also. And subscribe my channel so that, and click on the bell icon, so that whenever I upload a very new concept video, it will be helpful for you people. Thank you.